Hello and welcome to this physics video, resistors in series and parallel, U11.RSP2. And what we will be doing today is calculating the equivalent resistance for a circuit of resistors in parallel and finding the current in and potential across each resistor in the circuit. So we're going to need some information first before we begin. Currents in parallel circuits, the total current of the circuit is equal to the current of each resistor. So you add the currents of each resistor and you find the total current. Resistors in parallel, they work a little strangely than resistors in series. 1 over the equivalent resistance is equal to 1 over the first resistor plus 1 over the second resistor, and so on and so on. And finally, the potential difference in parallel circuits, the terminal voltage is equal for every resistor in the circuit. So for example, the potential difference on resistor 3 is going to be the exact same as the potential difference of the terminal voltage, as well as the same as the potential difference of the first resistor. So let's do some problems now. A 7-volt battery is connected to 3 resistors with values of 2 ohms, 3 ohms, and 4 ohms in a parallel circuit. What is the equivalent resistance of the circuit, and what is the potential difference across each resistor? Okay, so first we need to find the equivalent resistance of the circuit. So our equation is going to look a little like this. We'll just leave this as x. So we're going to need a calculator for this. And we get that value, and now we just have to divide that by 1. Oh, whoops. We have to divide that by 1 there. And there we go. That is our equivalent resistance. So now that we found that, before we find the potential difference across each resistor, we need to find the current. So we need to use this equation right here, our favorite equation. We know that it has the battery has 7 volts. We don't know the current, but we know that the total resistance is that. So we're just going to go 7 divided by 0.92, and that is our current. Okay, so now we have to find the potential difference across each resistor. So for resistor 1, we know that the voltage is going to be 7. Let me label this. The voltage is going to be 7. It's going to be equal to the resistor of 2, and we need to find the current. So that will be 7 divided by 2. We get 3.5. And also let me put amps here. Okay. So there we go. That's our first resistor. That's the first current for that resistor. So here we have, it's going to be 7 equals 3, and then we need to find the current. So 7 divided by 3. We get 2.3 repeating. And lastly, our third resistor is going to equal 7 equals 4x. So to the trusty calculator. 7 divided by 4, we get 1.75. And there we have it. Those are our three currents for our resistors. For the first resistor, we have a current of 3.5 amps. The second resistor, a current of 2.3 amps. And for the third resistor, a current of 1.75 amps. And our total equivalent resistance is 0.92 ohms. Alright, and that's it. That's how we calculate the current and find the potential difference across each resistor in the circuit. So thank you for listening, and I hope you enjoyed the video. Thank you.